Welcome back to The Explainer. Today we're taking a really fascinating look under the hood of heavy industry accountability. We're going to demystify exactly how corporate accountability and climate risk are measured, specifically within the coal sector. If you've ever wondered how massive, complex environmental and social impacts actually get translated into cold, hard financial metrics, well, you are in the right place.
Think about it for a sec. Measuring the value of a coal operation, it's not just about crunching the tonnage of what's hauled out of the ground. How do investors, regulators, and the public actually measure the long-term impact left behind? The water used, the waste generated, the community friction. These are hidden liabilities that can drastically affect a company's bottom line. Standardizing those invisible risks has always been a massive challenge. But the solution to that standardization problem actually lives inside a pretty intense framework. The International Sustainability Standards Board, or ISSB, which recently took over the SASB standards, maintains a highly detailed 40-page standard dedicated strictly to environmental, social, and governance reporting for this specific sector. It basically turns abstract concepts into trackable math. Here's our roadmap for today's explainer. We'll start by decoding the coal operations classification. Then we'll track emissions and resources, manage waste and biodiversity, look at community and indigenous rights, dive into workforce health and safety, and finally, wrap up with reserves valuation and capital. Let's get right into it. All right, part 1, decoding coal operations classification. So the ISSB uses something called the Sustainable Industry Classification System, or SICS. You can kind of think of this like a giant filing cabinet for the whole global economy. If we pull open the drawer labeled Extractives and Minerals Processing Sector, right there, we find our highly specific accounting code, EMCO, and that simply stands for coal operations. This little code is the anchor for literally all the metrics we're going to talk about. Now, the crucial point here is defining exactly who falls under this EMCO umbrella. And honestly, the standard is incredibly precise. It scopes in entities responsible for mining coal, so that's both underground and surface mining techniques, as well as those manufacturing coal products. It also explicitly applies to the extraction of both thermal coal, which is mostly used for electricity, and metallurgical coal used in steel production. If a business touches these operations, boom, they're held to the standard. And this brings us to the ultimate goal. These SASB standards, which are now under the IFRS Foundation, aren't just about environmentalism for the sake of it, right? They're really designed to help companies disclose sustainability risks that could reasonably mess with their cash flows, their access to finance, or their cost of capital over the short, medium, or long term. Moving right along to Section 2, tracking emissions and resources. This standard takes a super dense regulatory matrix and translates it into clear, hard requirements. For instance, companies have to disclose their gross global Scope 1 emissions, meaning the direct emissions from sources they actually own or control, like massive mine site equipment or methane seeping from coal beds. And that's all measured in metric tons of CO2 equivalent. Then, for water, they have to report the total water withdrawn and consumed. The kicker here? They have to highlight the exact percentage used in regions facing high or extremely high baseline water stress. And you know what? The standard leaves absolutely zero room for ambiguity. Like, how do we legally define fresh water to actually track it? Well, the framework dictates that if there's no local legal definition, fresh water is strictly defined as water containing less than 1,000 parts per million of dissolved solids. This is a hard threshold, and it prevents companies from kind of obscuring their true impact on usable local water supplies. Okay, Section 3, managing waste and biodiversity. So, coal mining obviously generates massive volumes of waste rock and tailings. A critical environmental hazard here is acid rock drainage, or ARD. This happens when surface water hits coal mining overburden, turns highly acidic, and basically leaches heavy metals straight into the local environment. It's nasty stuff. The SASB standard actually requires companies to mathematically predict where ARD is likely to happen across their sites and report the exact percentage of those sites undergoing active mitigation or water treatment remediation. On top of that, biodiversity impact is measured with pinpoint geographical precision. The standard throws down a strict 5-kilometer boundary. Companies literally have to disclose the percentage of their proved and probable reserves sitting within a 5-kilometer radius of protected conservation sites or habitats for endangered species. Basically, proximity equals serious financial and regulatory risk. Which leads us nicely into Section 4, community and indigenous rights. Let's look at how social risk is captured on the balance sheet. Companies are required to report the percentage of reserves located in or near indigenous land. Why? because a lack of free, prior, and informed consent can quickly snowball into major protests or permit suspensions. They track this through a pretty fascinating metric called non-technical delays. The company literally has to count the number of days their sites are shut down, not because a machine broke, but because of community resistance. And as we all know, lost days equal lost revenue.
Next up, Section 5, Workforce, Health, and Safety. Okay, check out this incredibly specific metric. How on earth do you fairly compare the safety of a tiny mine in one country to a massive sprawling operation in another? You use a standardized rate base. The standard relies on a 200,000-hour formula to calculate incident and fatality rates. That's not just a random number. It mathematically represents 100 full-time workers clocking 40 hours a week for 50 weeks a year. It perfectly sets a universal baseline so we can accurately track near misses and accidents across the entire global industry. And finally, Section 6, Reserves Valuation and Capital.
First things first, we've got to clearly distinguish the assets. Proved reserves are essentially a sure thing. The measurements are closely spaced, and the size and mineral content are locked in. Probable reserves are a step down from that. The measurements are spaced farther apart, but there's still a high enough assurance to assume the coal is actually down there. This distinction is absolutely crucial because it forms the baseline for estimating exactly how much carbon dioxide is physically embedded in the ground, just waiting to be mined.
Which brings us to the ultimate million-dollar financial question. What happens to the value of all these proved and probable reserves if global climate regulations suddenly tighten up, or say carbon emissions are aggressively taxed? Is it even going to be economically viable to pull that coal out of the earth? To answer that, companies actually have to stress test their future. Under this standard, they are required to disclose the sensitivity of their reserve levels against future price projection scenarios published by the International Energy Agency. They've got to show exactly how many tons of reserves stay economically viable under a current policies baseline, a new policies scenario, and finally, a sustainable development scenario.
Now, understanding the severity of that last test is key. The sustainable development scenario literally forces coal companies to mathematically project the survival of their entire business model and their reserves against a global energy pathway that limits temperature increase to 1.5 degrees Celsius. It is a brilliant, transparent accounting of climate transition risk.
As we wrap up this explainer, I want to leave you with something to chew on. By forcing companies to measure things like water stress, community protests, and future carbon pricing, this classification standard drags the hidden realities of heavy industry right into the light. So, if global climate policy completely rewrites the fundamental math of energy, how much of the world's currently proved coal is already an unminable liability, forever trapped in the ground? Thanks so much for learning with me today, and hey, keep asking those hard questions about the data behind the disclosures.